Now I'll explain about perfectly elastic collision. Perfectly elastic collisions are nothing but the momentum before the collision and after collisions are equal. That is nothing but momentum is conserved, and kinetic energy before the collision and after the collisions are equal. That is nothing but kinetic energy is conserved. So we will consider one directional head-on collision. Head-on collision is nothing but collision happens along the line connecting the centers of the two masses which are going to collide. So kinetic energy is conserved, that is nothing but initial kinetic energy is equal to final kinetic energy. Momentum is conserved, that is nothing but P1 is equal to P2. So kinetic energy conserved, so these two collides, and after collision that goes in two different both of them are maybe same mass or different mass. So initially M1 comes and collide with M2. This is having initial velocity u1, this is having initial velocity u2. So two masses was going, this was coming with high speed, they collide. Then after collision, they have gone in this direction. This is final velocity of mass 1, this is final velocity of mass 2. First, I'll write an equation for kinetic energy conservation. So this represents before collision, this represents after collision. What is momentum before collision? M1 u1 plus M2 u2. What is momentum after collision? M1 v1 plus M2 v2. From the conservation we can say that these two are equal. Now what is the kinetic energy before collision? Half M1 u1 square plus half M2 u2 square is equal to half M1 v1, the capital final velocity square, plus half M2 v2 square, where M1 and M2 are these masses, U1 and U2 are initial velocities of mass 1 and mass 2, V1 and V2s are nothing but final velocity of mass 1 and mass 2. I will cancel all half terms, these are common. I'll do one thing, I'll take M1 terms together from this equation. So I'll be having M1 U1 square minus M1 V1 square is equal to, I have M2 V2 square here. I'll take M2 V2 square, M2 U2 square that side. So I'll be having M2 U2 square here. Now M1 U1 square minus M1 V1 square. I'll take M1 outside. Then U1 square minus V1 square is equal to M2 into V2 square minus U2 square. This is U1 square minus V1 square, A square minus B square. This is also V2 square minus U2 square, A square minus B square. So M1 into what is A square minus B square? We know that A plus B into A minus B is nothing but A square minus B square. So we are going to get the reverse done. So U1 square minus V1 square is nothing but U1 minus V1 into U1 plus V1. Here M2 into V2 minus U2 into V2 plus U2. I'll continue this side. Now I'll do one thing, I'll take M1 terms together from this term. So you have M1 U1, then M1 V1 is equal to, I'll take M2 U2 that side. So you have already M2 V2 here minus M2 U2. I'll take M1 terms out. U1 minus V1 is equal to M2 into V2 minus U2. Now you know M1 into U1 minus V1 is equal to M2 into V2 minus U2. You have M1 into U1 minus V1 here. So instead of that I am going to substitute M2 into V2 minus U2. So here instead of M1 into U1 minus V1 I am going to substitute M2 into V2 minus U2 because both of them are equal. Then U1 plus V1 is equal to M2 into V2 minus U2, V2 plus U2. Why we have done? Because we have M2 into V2 minus U2. Now we got M2 into V2 minus U2 in LHS also. So we can cancel these two. Then I can say that U1 plus V1 is equal to U2 plus V2. U1 plus V1 is equal to U2 plus V2. Or I can say that U1 minus U2 is equal to V2 minus V1. Now we know that this will collide only when this comes at higher velocity than this, then only I can collide, right? If this is moving at high velocity, if this is lower, then the distance in between them increases. So initially u1 was, see, this is velocity of approach that keeps on approach, that at every time that goes towards it, or I can say this is approach what basically happens. Now we know that, see, this is positive, so this also has to be positive, which means that your final velocity of second body is more than the final velocity of first body. Or I can say that this was initially having higher velocity, now the velocity has decreased and become v1, and this has got higher velocity. So this is basically, if this is more than this, then this will go away from it, or I can say that this is velocity of separation. So here relative velocity of approach is equal to relative velocity of separation. Now we will do one thing. We have equations, we have these equations. I'm going to rub all these things. This is an important equation. Now I will substitute. We need to finally find what is final velocity of mass 1 and final velocity of mass 2, because initial velocity will be given. So to get velocity of v1, we will first get what is v2 here, because to find velocity of v1, to find v1 we basically need to substitute for v2 in this equation. I'll tell you, v2 is equal to u1 minus u2 plus v1. This I am going to substitute in this equation, which is nothing but m1 into u1 minus v1 is equal to m2 into v2 minus u2. For v2 I am going to substitute this u1 minus u2 plus v1, then you have u2. m1 into u1 minus v1 is equal to m2 into instead of v2 u1 minus u2 plus v1 minus u2. Here I can say that m2 into u1 plus v1 minus 2u2. Just multiply this inside. m1 u1 minus m1 v1 is equal to m2 u1 plus m2 v1 minus 2 m2 u2. Now our objective is to find final velocity of the first mass. So final velocity of the first mass is nothing but, see, we have to get v1 terms together. So I'll keep m1 u1 here itself, m1 u1, then m2 u1. I'll take v1 terms together. I have m2 v1 here. I'll take m1 v1 also. So this I have taken, this I have taken, this I have taken into consideration, m1 u1. Then m2 u1 also I have taken into consideration. Now I have to take this 2 m2 u2. So I can take u1 in common here. u1 into m1 minus m2 is equal to 2 m2 u2. This is nothing but I can take v1 in common, m1 plus m2. Again I am rubbing this. From here v1 is equal to nothing but u1 into m1 minus m2. u1 is equal to, this is not equal to, this is equal to, this is minus, this is plus, sorry, this is plus. So plus 2 m2 u2 divide, see, on the LHS you are having u1 into m1 minus m2 plus 2 m2 u2. So u1 into m1 minus m2 plus 2 m2 u2. Then I am going to take m1 plus m2 to the denominator, so that I will be only having v1. So v1 is equal to whole divided by m1 plus m2. So the equation will become m1 minus m2 divided by m1 plus m2 into u1 plus 2 m2 u2 divided by m1 plus m2. This is the equation for final velocity of the first object. Now we have substituted for V2 and we got the equation for V1. Now similarly, if you are substituting for V1 in the same equation, the same way, you will be finally getting V2. So this is nothing but M1 and M2 are masses. So M1 minus M2 into U1 divided by M1 plus M2 plus 2 M2 U2 divided by M1 plus M2.